Alright guys, so today we're going to be talking about the squeeze theorem, and you'll notice over the course of this week the notes aren't necessarily going to line up with the days because you guys have already done limits. So if I come here and I look at what all is going on, what you've already done, so when I go to College Board and I look at that course at a glance, in pre-calculus, you guys did almost every single part. This is on page 27 PS of chapter 1 or unit 1. So you already talked about all these areas. The one area that you guys didn't talk about is 1.8 and defining limits using squeeze theorem. So that's what we're going to spend some time on today and in today's notes. All the rest of these guys are outlined in your OneNote. If you go into that content library and you go to these completed notes, these are all outlined in accordance with the College Board. So you'll be able to access any topic that you are unsure about. So let's check out the squeeze theorem. Squeeze theorem is kind of one of the coolest theorems in mathematics just because it is used a decent amount, but it also has such a name that doesn't really feel super mathematical. This is sometimes also referred to as the sandwich theorem. So if you ever hear sandwich theorem, aka it means the exact same thing. And there's a lovely little one-pager linked if you guys prefer to see it all worked out online as well. So the squeeze theorem is a technique used to conform the limit of a function by comparing it with two other functions whose limits are easily known or computed. So what we're saying is that the squeeze theorem is literally also called the sandwich theorem because one function is squeezed or sandwiched between two others. So if I'm looking at my x and y axis, if I had function, let's just use the same functions here as it's in your image. Function h of x, let's say it looks something like this, just like your image does. And then we have another function f of x that's below h of x. And then let's say a function exists, same as in your notes, as g of x, and g of x is in between, or squeezed or sandwiched in between h of x and f of x. So if it were a sandwich, right, then the h and f would be the breads and g of x would be the meat. So it's literally squeezed between the other two functions. All we're saying, and this is the proper notation, let's call this guy right here L for the limit, and this value is C. We're saying that the limit of h of x as x approaches c equals L, and the limit of f of x as x approaches c is also L, and you know that f of x, oops, let's see, running out of room here, is less than, let's just draw that below, g of x is greater than f of x and less than h of x. Therefore, the limit of g of x as x approaches c is also L. Now, this looks like a lot of scary notation, but all we're saying here is the limit of h of x, so that's this gold function up top. If this guy has a limit, or that output, right, is we're approaching c, is going to be the value L. And also the function that's below this f of x, right, as f of x also approaches c, that limit is L. We're saying that because g of x is in between both of those values, it also has to be equivalent to that output. Let's try it out here on this first example using proper notation. So we're given two things. We know that 1 is going to be, or f of x lies between 1 and x squared plus 2x plus 2. So we want to find the limit as x approaches -1 of f of x. Well, let's start off with our easiest function. The limit as x approaches -1 of the function 1 is going to equal 1. Because if I'm thinking about this on a graph, the value of 1, regardless of where we're at, if my input is -1, if my input is positive 1,000, my output is still going to be 1. Now I'm going to find that other hand. So the limit of x squared plus 2x plus 2 as x approaches -1. Remember, we'll just plug that in. And when I plug in all of those values, I would also get 1. Since both of these values are the same, that x squared, right, would be something that looks like this. So I know something that looks like this. My middle function, my f of x, is going to live somewhere in between those two functions. So I'm going to say, therefore, the limit as x approaches -1 of f of x equals 1. And I'm going to say by Squeeze theorem. Because it's stated above that f of x is squeezed in between both of these functions, and since both of those functions have equivalent outputs, I can say that that middle function also will have the same limit since it lives between. Let's take a look at another example. So the big thing here, guys, is the notation. Suppose f of x and g of x are boundaries of h of x, as shown on the graph below. Given that f of x is the natural log of x plus x squared, and g of x equals e to the x minus 1 for all x in the interval containing x equals 1, except possibly at x equals 1 itself, find the limit as x approaches 1 of h of x and justify. So here's h of x right here. It lives between both of these limits. So we need to evaluate both g of x and f of x at 1 so I can determine what the value is going to be of h of x. So I'm going to just start here with a simple evaluation, and then we're going to use the squeeze theorem to prove the rest. But I'm going to first start off with saying the limit as x approaches 1 of g of x. We'll start off with this guy. If I were to plug in a 1, e to the 1 minus 1, e to the 0 power is going to be 1. And then let's get that f of x. Limit as x approaches 1 of f of x. If I plug in a 1, the natural log of 1 is 0 plus 1 squared is 1. So right now it's already looking like that limit or that value of h of x as x approaches 1 is also going to be 1. But we need to prove that from both left and right hand sides because one of these functions doesn't live on top of the other function the entire time. And as we both know when we're doing limits, it has to be evaluated from both the left and right hand side. They have to approach the same value for it to equal that number. So let's get that written in here. We're going to say, we need to make a few statements as we're going through this. So our first scenario, we'll deal with that left hand side. So I'm going to say for x is less than 1, when I'm looking at x is less than 1, g of x, actually I should probably flip that around so my inequalities don't get confusing. Let's say f of x is less than h of x is less than g of x. And in this scenario, the limit as x approaches 1, and we're going on the left-hand side, so I'm going to say from the left, of f of x equals 1. And the limit as x approaches 1 from the left-hand side of g of x equals 1. So I can say, by squeeze theorem, that's also going to be true for h of x. After you get that written down, so this was part 1, we needed to do it for x is less than 1. So for part 2, I need to go about and do it for x is greater than 1. For x is greater than 1, very similarly, we're going to write a statement, but we're going to flip those around. Now g of x is on the bottom. or is the least value function. H of x is in between, and f of x is on top. And now since we're looking for x is greater than 1, we'd be approaching that 1 from the right. So you need to rewrite your limits. Please pause and try to write this out, and then check your work when you're done. All right, you might notice that I threw a little bit of a different notation here. Instead of writing them out separately, I just said that from g of x, so from the bottom function to the top function f of x, they both are equivalent to 1. That works just as well as this other. So then we have to round this up with our final statement here. Remember that a limit can only exist if it is approached by both the left and the right. So I'm going to say the limit as x approaches 1 from the left of h of x equals 1. And the limit, let's just say both of this at the same time, as x approaches 1 to the right, h of x, all of this equals 1. There we go, that's better. So therefore, make sure we're saying that we use Squeeze Theorem to get this. Because we squeezed in between the limit of h of x as x approaches 1 equals 1. All right, guys, that is all. Make sure you have some sort of a notes that contains all this information, and we will be talking about this and practicing with limits in class. I will see you guys in the morning.